Welcome back, guys, and now we're going to talk about ADC and analog inputs. An ADC takes an analog signal and then it converts it to a digital signal. Now, what I mean by analog signal, a voltage, for example, is an analog signal. And this voltage can vary, and this variation can be translated into some digital values like 10, 10, or whatever. And this analog value is going to be translated to some string of binary signal, okay? So we call it analog because it can change within a whole range. So for example, let's say that you have a voltage source and it is varying between 0 and 5. This variation is an analog signal. And well, the Arduino, let's say, or any embedded board, if it has an ADC circuit in it, it can take it and translate it to something binary. I mean, let's say you have 5 volt connected to that board. This 5 volt, let's say you try to present it in a 3-bit system, it's 101. So you put a 5 volt and your Arduino or any board is going to sample that signal and it's going to translate it to this binary string, and then it's going to comprehend it as 101. Okay, and then you can do whatever you want with this 101 information. Same thing, maybe we drop the voltage a bit to 2 volt, and the representation in 3 bits is 010. And then the Arduino will understand it as 010 after it samples it, and it gives you this binary string representation. So this is how we actually read any analog value. I mean, temperature sensor, humidity sensors, resistance, pressure sensors, all of these are about analog signals that is translated to some electrical signals and then sampled inside an embedded system to give you a binary string. So I'm going to give you an example of a variable resistor connected to a voltage source. So if you change the resistance, voltage it changes. If you don't have any knowledge about electrical circuit calculations, there is a very simple law. And if you have a very, very basic math knowledge, you would understand it. We're saying that voltage is the current multiplied by resistance. Now, you know that if you change one side of the equation, let's say we are changing resistance, this voltage is going to change, right? So this is how we have a varying voltage. Remember that we took an example of a voltage changing in between a certain range. In order to change it, there is a resistance in the equation. Whenever we change resistance, voltage will change as well. So this change in voltage is one of the very famous forms of analog signals. I mean, let us take an example. This is a variable resistance, okay? And it is represented like this. It has this zigzag line and there is an arrow going through it. So if you connect some voltage to this resistance, you're going to get another voltage at the output right here. So let's say the voltage here is 5. There is a resistance. It's going to decrease the voltage. And then you get another voltage here, let's say 2.4. You can imagine it as water going through pipes, and these pipes' diameter is changing. Let's say it's shrinking, so less water will come in, meaning that in our case, in electrical signals case, less voltage will come. So this is water, 5 volt, let's say. There is a pipe, the pipe diameter is decreasing, meaning less water at the output. Okay, same thing here. It is almost the same analogy. Okay, so the Arduino has inputs that are called analog inputs. We've studied before digital inputs, and we have connected the switches to it. A switch can conduct either 5 volts or a 0 volt. But for analog input, it can read a whole range of values, all between 0 and 5 volts. Okay, so in our case right here, the 5 volt is being decreased to 2.4, and the Arduino is taking this 2.4 and converting it to something binary. I mean, if we play with the resistance, let's say that we have changed the resistance so that the voltage is decreasing. The analog here, let's say we read 1.2 right now because we have changed the resistance. Let's say that we have changed the resistance again. We might see a voltage of 4.7 at this point right here, and this will be converted to binary. And this conversion to binary is very similar to what we were studying in unsigned variables in VHDL. Remember unsigned variables and how we studied that it depends on what is the length or what's the binary system. Is it 4 bits? Is it 8 bits? It's going to give you different decimal numbers. It's the same conversion. we take an analog value and then it's translated to a binary of strings depending on the architecture of the Arduino. If it is 8 bits, 16 bits, 32 bits, 64 bits, it will be translated to some binary string numbers. And that's it. This is all you need to know for now about ADCs. Now, ADCs can be very, very complicated in terms of sampling, but we won't be getting into that for now. We just want to understand the basic idea. When we heard the term ADC, what does it mean and what does it do? So it basically only takes an analog value and just converts it to some binary string. And this binary will be understood by Arduino, and you can take this binary or decimal or whatever number then the Arduino will change it to, and you can play with it, put conditions, and actuate your Arduino accordingly.